Alright guys, so in this short video, we're going to talk about separation of variables with a natural log case, because this is something kind of interesting that's going to actually come up a lot. So suppose I tell you that dy dx equals 2xy, and I tell you that y of 0 equals -4, and I ask you to find the particular solution. So go ahead and try and work out the algebra, and then let's see how far you can get before we get to something that's kind of interesting. So when we go ahead and divide, we get dy over y equals 2x dx. So that's normal, right? We divide the y and multiply the dx. But now when we integrate both sides, the integral on the right, of course, is very easy. The left side's a little trickier, right? When you integrate a 1 over x dx, we don't just get ln of x, we get ln of absolute value of x. So let's go ahead and put that. So ln absolute value of this y right here. Okay, now, again, this is the easy case where you want to just go ahead and plug in to find c. Nothing special there. So we're going to plug in 0, -4. So ln of absolute -4, such as ln of 4, equals 0 plus c. So ln of 4 equals your c. So that tells us that the natural log of absolute y equals x squared plus the natural log of 4. Now again, our goal is to solve for y. That's what we're always trying to do. We're trying to get an equation for y. So what we're going to do here, what's the opposite of natural log? E. So we're going to raise e to the power of each side. Now we want to be really careful when we raise e to the power of the right side, because a bunch of chumps in Miss Cruzy's class are going to say, oh, if I raise e to the power of two things, that's just e to the first plus e to the second. Well, no, sir, that's obviously wrong, right? X squared plus x to the third is not x to the fifth. So what you're going to do is if you have e to the a plus b, you could just keep it all like that. If you got to separate it, you could do like e to the a times e to the b, like that. So what we'll do here, we'll cancel that out. So we'll get absolute value y equals e to the x squared plus ln of 4. I put a parentheses around the whole thing. It's all in the exponent. Okay, now let's talk about the absolute value, because something interesting happens with the absolute value here. Now, just a reminder, back in Algebra 1, if you solved an equation, like say you had absolute value x was equal to 5, that x could be positive or -5. The absolute value led to a plus or minus as well, because you could have a positive or a negative inside the absolute value. So what that means is the absolute value is going to lead to a plus or minus. So y equals plus or minus e to the x squared plus the natural log of 4. And we're going to do the same thing we did in the square roots. Again, we're going to plug in the 0, -4 again, and that's going to help us determine whether it is a plus or whether it is a minus. So let's do that. So I'm going to get, just plug it in again, so -4, and again, this is going to work out very straightforward, equals e to the 0 plus ln of 4. So does -4 equal positive or negative e to the ln of 4? Well, that's just 4. So does -4 equal positive or -4? Well, obviously it's the negative. So it's very important that you get that absolute value getting you a plus or minus there. So if we know it's the negative, let's go back here. So we'll write that as y equals -e to the x squared plus ln of 4. This is a perfectly acceptable answer, and I would encourage you to leave it like that. Occasionally, when you're looking at answer keys or in a textbook, they might split this up to be e to the x squared times e to the ln of 4, and they might rewrite that as, that's 4 times e to the x squared. Again, it's the same thing, right? These are equivalent ways. I just don't like simplifying, so I'm going to prefer to leave my answer like that. But if they're multiplied, it is equivalent. Okay. So let me show you just one more example like this. This one's a little weird because I'm going to give you one with no x in it. So a lot of you guys, you want to take x's out of your life, so you might end up with something like this. dy dx equals 2y plus 1. And you might be confused because there's no x in this equation. So this is saying, the rate of change is just equal to 2 times the y equation plus 1. All right, and I'll tell you again, let's say y of 4 equals 0. We'll just flip it there. So then what we'll do is, okay, first off, I'm going to multiply the dx to both sides. So I'm going to get dy equals 2y plus 1 times dx. So don't worry, the x is going to show up. Let's go ahead and divide that to the other side here. So I'm going to get dy over 2y plus 1 equals just dx. Now when we slap at the integral stick, the right side, that's where the x is going to appear, because you're basically integrating on 1. You're integrating 1 times dx. So that's just going to be x plus c. On the left side, that's where we need to go ahead and do an actual little u sub here. So don't be scared to bust out the u sub. Your u is 2y plus 1, so the derivative of that is a 2 dy. Okay, so we'll put a 2 here, we'll put a 1/2 in front. So that becomes 1/2 integral 1 over u du. So that gives me 1/2 ln of u equals x plus c. Now we'll just plug that back in. ln of 2y plus 1 equals x plus c. Okay, so now at this point in time, now let's plug in this 4 comma 0. All right, so that's my x and that's my y. So I'm going to get 1/2 ln of, just 1 equals 4 plus c. The ln of 1 is 0. So that helped us out really nicely. So that just tells us that my c is -4. So I get 1/2 ln of 2y plus 1 equals x minus 4. Okay, now we got to solve for y. That's my goal. So let's unpack this a little. We'll multiply the 2. So ln of 2y plus 1 equals 2x minus 8. Now we'll raise e to the power of both sides. So e to here. So we'll get, absolute value 2y plus 1 equals e to the 2x minus 8. All right. So then from here again, the absolute value is going to lead to a plus or minus. So 2y plus 1 equals plus or minus e to the 2x minus 8. All right. So this is the point again where I just plug in the 0, what was it? It was 4, 0. So I just plug in the 4, 0 here. So when I do that, I get 1 equals plus or minus e to the 0. Okay, does 1 equal plus or minus 1? Well, I have a brain, so I think it's the plus. So I'll get 2y plus 1 equals plus e to the 2x minus 8. So as soon as I got the plus or minus, that's the easiest time. Just like as soon as you get the c, that's the easiest time to plug in. So now we'll just solve for the y. So 2y equals -1 plus e to the 2x minus 8. So then y would be -1 plus e to the 2x minus 8, or e to the 2x minus 8 minus 1 divided by 2. Okay, and that's how I'll find that. So that's separation of variables with the ln case. The absolute value leading to a plus or minus, that's kind of the interesting step we got to be aware of here. One more thing I wanted to talk about, not really relating to this, but just talking about like a second derivative. Okay, the second derivative, because they like to ask these questions on the AP test. So they'll tell you, here's the equation for differential equation. Say my dy dx equals y squared minus 3x. And they'll ask you to find that second derivative in terms of x and y. So what we're going to do here is we're just going to use implicit differentiation. And we use implicit differentiation, just like related rates or whatever, remember that we need the dy dx. So I'll take the derivative of both sides of the equation. So the derivative of the derivative, that's the second derivative is d squared y dx squared. When we take the derivative of y squared, it's 2y times the derivative of y dy dx. Derivative of 3x is 3. Now, the only thing we're going to do here is because we have an equation for dy dx, we're just going to plug in that dy dx equation. So when I plug in that dy dx equation, I'm going to get 2y times. I'm just going to go back and plug this in. So 2y times y squared minus 3x, and then the whole thing minus 3. So that's how we can find the second derivative. It just relies on the equation for the dy dx. Okay, people, thank you so much for watching. Second derivatives, partial solutions, particular solutions with ln's, very exciting stuff. Let me know if you have any questions, bring them to class, and I'll see you all soon.